All right. We are going to look at two more from 2.6. These are the last two because we didn't do any that had these kind of funky things. We have our absolute value, we've got a fraction, and we've got a greater than. So if we had our, fraction where it was less than 0, greater than 0, that's a whole lot easier to deal with because we just care about when it's, positive or negative. With these ones, we actually do need a little bit more information. So when we have something that's an absolute value that is greater than or equal to 2, a lot of times I think this is really helpful to think about it on our number line. Because if I know that this could be greater than or equal to 2, it could be greater than 2, right? It could go that way. I'm going to fix that 2 because that 2 looks weird. There we go. Or we could think about negative 2, and it would need to be this way. If it is smaller than negative 2, then my absolute value, so something smaller than negative 2 would be like negative 3. The absolute value of negative 3 is a positive 3. 3 is greater than 2. So when we have these greater thans, we're a lot of times going to have an or, where we're going to have this or that. So greater or this or that. So we're going to need to set this up as two statements. So my absolute value could be just greater than 2. It could exactly be that my 2 minus 3x over 5 is greater than or equal to 2. That might be exactly what we have. Or my fraction, my 2 minus 3x, that's an x, divided by 5, could be less than or equal to my negative 2. So when we have these, those are closed in, greater thans, we need to be really, really careful that we're getting both directions. Because greater means it's going away. We have a lot of options on two separate ways. So we're going to solve each of these fractions individually. I'm going to zoom it in because then my handwriting gets better if I can write not molecularly small. So if we look at just this green one over here, what can I do to try and solve this thing? Multiply by 5. That's going to give us our 2 minus 3x, is what that says, because that looks like crazy pants, less than or equal to negative 10, because we're times by 5, times by 5. Then what are we going to do? Subtract the 2. Minus 2 minus 2. We get negative 3x is less than or equal to negative 12. What next? Yeah, if we divide by this negative 3, whenever we multiply or divide by the negative number, that sign changes. So this side is going to become that x is greater than or equal to 4. And then we're going to do the same thing with the other fraction. Very same vibe. We're going to take and multiply by 5. So we're going to have our 2 minus 3x is greater than or equal to positive 10. This was times by 5. This one is times by 5. And then again, we're going to subtract our 2. We're following those exact same steps because these statements are going to be exactly the same. So we follow these exact same steps. That's going to give us our minus 3x is greater than or equal to 8. And when we divide by our negative 3, switching that sign, we're going to get that x is less than or equal to negative 8/3, which is totally fine, and it's a thing. Our answers, though, need to be written as our interval. Oop. So we need to make sure we're doing that. And again, if it helps, draw it on your number line. because we have two separate pieces here. We have that my x is going to be greater than or equal to 4. So I could at 4, and I know it's going to be greater than. And we're going to have our negative 8/3. So I'm going to put that over here for our negative 8/3. And it needs to be less than. So it needs to be this way. So when we're writing our answer, our interval notation, I'm going to have two intervals. We're going to have from negative infinity up to our negative 8/3. Infinity always gets a parenthesis. Since we have an equals to, this one gets a bracket. And from 4 all the way up to positive infinity. Again, parentheses on infinity, bracket on 4. If we want the most technically correct, we join them with a union, a U. I'm not going to be petty about the U. You put and, right or. Is
the answer still going to be like that if the sign were different and the x was like less than something?
Oh, like up here? For the most part, if it's a less than, it's going to be between the two because the distance will be less than, like, so say if it was less than 2, my absolute value, my distance would be less than 2 and negative 2, so it would be between them.
Okay.
So when we have a less than, for the most part, we're going to wind up with a between, but not necessarily always because we're going to look at the one on the right too. The one on the right's a little bit weird too. But usually for a less than, it's between. For a greater than, we get this or that. Greater, we get two pieces. So on one like this one, where we have an absolute value in isolation in our denominator, gross. What we're going to do is we're going to basically treat this kind of like its own x. And we've got to get this piece out of the denominator before we can do much. So what we're going to do is we're actually going to multiply both sides by this absolute value. Absolute values by themselves are always positive values, so it's not going to mess with our sign. So I can multiply by my absolute value of 5 minus 2x. That's going to get the absolute value out of the denominator. Now we want to try avoid doing this as much as we can, but it's really the only way to deal with this guy. We want to try really hard not to be moving the absolute values, but this guy's just unpleasant. Because when we multiply by this absolute value, that guy cancels out. And we're going to have our 3 is less than 2 times the absolute value of 5 minus 2x. This is way less ugly to deal with. This we can do. It's not pleasant, but we can do it. What are we going to need to do first? Divide by 2. We want that absolute value in isolation first. We should divide by 2. That guy and that guy are going to cancel out. That means I also need to divide this side by 2. So we're going to have our 3/2 is less than absolute value of 5 minus 2x. So now my x is on the right-hand side instead of on the left-hand side. So is my distance going to be more than 3/2 or is my distance less than 3/2? Remember, crocodile eats the bigger one. Alligator, depends on what genre you're talking. So that's how it's going to be bigger. So if my distance is more than, it's greater. So even though this is a less than, my distance is more than, so we're going to be away from. My absolute value is going to be more than 3/2. So when we have these set up facing the other direction, we got to be really, really careful about thinking less than's between, greater than's away. My distance is more, which means if we think about our 3/2 and our negative 3/2, if my distance is more, it's going to go that way. Or if the absolute value is more, that way. Because this piece is bigger than this piece. So the absolute value is all about our distance. So when in doubt, if you need to sketch it down to your number line so we can see, this distance needs to be greater. So we got to be greater. You don't have to draw the number line, but I find it usually helpful because it helps us remember that I need my 5 minus 2x to be less than -3/2. And I need my 5 minus 2x to be greater than my 3/2. Okay, so be really, really careful with these ones. The book loves to play tricksy games like putting stuff in weird orders. I love to play those kinds of weird games. So let's get these down, all the way down into our intervals. Because what do we need to do on this one? Subtract 5. So we get -2x is less than, what is -3/2 minus 5? -13/2. You could also multiply everybody by 2 and get rid of your fraction. Totally valid. You're going to wind up at the same answer anyway. Then what do we need to do? Divide by -2. And whenever we divide or multiply by a negative number, we need to switch that sign. So my x is going to be greater than, what is -13/2 divided by -2? Ooh, yep, I heard it. 13/4. You can also think of this as, I'm just going to switch colors here, our -13/2 times 1/2. Divide by 2 is the same thing as times -1/2. If that helps, think of it that way, and that's sometimes a little easier to come across with our 13/4. And then again, we're following that same process over on this side. We're going to minus our 5 from both sides, giving us our -2x is greater than our 3/2 minus 5. We get our -7/2. And then we divide by our -2 again, making sure we switch our sign. And we're going to have our x is less than 7/4. So be really careful when we're setting up our intervals because they flip-flopped on us. This is now my smaller interval. X is less than 7/4. This is now a bigger interval. X is bigger than 13/4. So my interval notation for my answer, we're going to have our -∞ up to 7/4 and our 13/4 up to +∞. Technically, we join them with a u, but I'm not going to be mad at you. But you could put and, you could put or. I don't really care how you join them up. Technically, u is the best option as a union, but I'm not going to be petty about how we put our two intervals together. So these are gross in 2-6, dealing with these fractions and the absolute values all at the same time. Questions on these two? Because we only have one more section left to go, and it's going to keep dealing with these inequalities, and we're still going to be getting these interval answers. They're going to look weird. I promise they're not as bad as they look, though. Okay. So we're going to deal with things that look like this. So they're going to look a lot more polynomial-y. And we're going to start out by giving them to you guys in factored form. So this one is a quadratic. I've got two x's in it. What we're looking at here is we have a quadratic. And just in general with our quadratics, they look kind of like this. All right? Quadratics look vaguely like that. And what we want to know is when is this quadratic, hypothetical this one, greater than 0? I want to know what intervals it's above my x-axis. So we're going to have more than one piece that have places over our x-axis. So really what we care about is where are our zeros, and how does that mess with, like, think about our end behavior, that kind of stuff. So we're going to find our zeros. I'm going to draw them on a number line, and we need to figure out where it's positive and where it's negative. Because if I want this thing to be greater than 0, I need to know where it's positive. So the first thing I need are my zeros. Where do we have zeros or roots? So from this factor, 3x plus 1, we're going to have one at negative 1/3. I heard that one. Because if I set my 3x plus 1 equal to 0, 3x plus 1 equals 0, 3x equals negative 1. Divide both sides by 3, x equals negative 1/3. What is our 0 for this one? Not 2. 1/2. Because I subtract 5 from both sides, we get negative 10x equals negative 5. Divide negative 10, and so we get negative 1/2. So this parabola, because it is a parabola, positive 1/2. You're right. If I sketched it, we would have our positive 1/2 as a root and our negative 1/3 as a root. So what we want to know, and this is how, like, we could eyeball this on this one, but we're going to practice setting this up like we would for polynomials because we're going to start getting more pieces. I'm going to set this up with my zeros on a number line. And I always go from smallest to biggest. It makes things kind of easier to think about. And then I'm going to set up like kind of a mini table down here. And I'm going to put each of my factors, or if I have a leading coefficient or anything like here, I'm going to list those all right here. And I'm going to make a table. And what we're making here is something called a positivity table. We will use this several times for several different kinds of functions throughout the year. So this is called a positivity table. I'm going to take my 3x plus 1, and I'll make a line for that. And I'm going to take my other factor, my 5 minus 10x, and I'll make that its factor here. And what we want to know is we know that this polynomial will equal 0 right at these roots. These are our zeros. That's where things are going to be changing signs. So if I think of a number that is smaller than negative 1/3, so if it helps, think of something smaller than negative 1/3, like negative 1, or negative 2, or negative 10, anything. If I have a number smaller than negative 1/3, is this piece, 3x plus 1, going to be positive or negative? Negative. Because if I think of negative 1 as my x, negative 1 times 3 is negative 3. Negative 3 plus 1 would give me negative 2. So that piece is going to be negative. If I think of that smaller than negative 1/3, so again, you can think of it being like a negative 1. And I substitute that in here. 5 minus 10x. Is this piece going to be positive or is this going to be negative? 5 minux 10 times negative 1? Positive. Because, and like when in doubt, put it in the calculator. 5 minus 10 times negative 1. That's the same thing as 5 plus 10. So in this section, left of my negative 1/3, I'm going to have a negative piece and a positive piece. Well, if I have a negative piece times a positive piece, is this going to be negative or is it going to be positive? What is a negative times a positive? A negative. So left of my negative 1/3, we have a negative function. So this whole thing is going to be negative. This graph is pointing down this way. Then we're going to think between negative 1/3 and 1/2. So what is the number between negative 1/3 and 1/2? 0. We like 0. 0 is a lovely choice. So if we have 0 in 3x plus 1, is that going to be positive or negative? Positive. If I put 0 into 5 minus 10x, is that going to be positive or negative? Positive. So if I have a positive factor and a positive factor, is my whole function going to be positive or negative? Positive. So all the way between negative 1/3 and positive 1/2, we have a positive value here. Doing the same thing over here. A number bigger than 1/2. You can think 1, you can think 2, you can think 100. It doesn't really matter. Anything bigger than 1/2. So if we have 3x plus 1, and we have a number bigger than 1/2, is that going to be positive or negative? Positive. If we have a number bigger than 1/2, 5 minus 10x is going to be positive or negative? Negative. So our function, is it going to be positive or negative in this section? Oopsies. Not the laser pointer. Positive times a negative? Negative. So I know if I'm looking at this quadratic, granted we know that because it's a quadratic, that it's going to point down over here. We know whether we're above or below an x-axis. So we want to know where it's greater than 0. We want to know where it's positive. So our interval where we're going to have our solution is going to be this piece right here. That's what's showing us the part that is greater than 0, this whole section. So our interval where this quadratic is greater than 0 is going to go from our negative 1/3 up to our positive 1/2. Are we including our zeros in our answer here? Can it equal 0? No. And do either of these give me a 0 in my denominator? No. So our interval is going to be in parentheses on both of them, because they can't equal 0 because we have a greater than. So we find our roots, we make a positivity table, and we're going to go from there. Because we're not just going to give you quadratics. Quadratics we know a lot. We're just starting with a quadratic because we know those and we're more comfortable with them. Okay, so we're substituting pieces in. Or at least kind of mentally substituting them in. Okay, I know it feels really silly to do that with a quadratic. It feels like we're overthinking it really, really lots. Sometimes we give you polynomials though. And they're a little bit harder to kind of sketch out and see. But we're going to do very similar pieces here. So we want to figure out where this polynomial is less than 0. We want to know where it's negative, where it's below my x-axis. So what we need to figure out first is we need to find our zeros so that we can make our positivity table. And again, we're going to use these positivity tables for a lot of things. This is just kind of where we're learning them. So what do we get for our zeros on this? We're going to have our negative 2. That's going from this guy here. Our positive 1. That's this guy here. Yep, but we need to subtract our 4 from both sides. Minus x equals minus 4. Then we divide by our negative 1. and we get positive 4. When in doubt, write it out. 4 minus x equals 0, minus x equals minus 4, x equals 4. So when in doubt, you can write it down. But we need our zeros first. And we're going to set them up. We're going to put them in smallest to largest order. It makes things a lot easier if we do. With our minus 2, our positive 1, and our positive 4. Then I'm going to write each of my factors. I'm going to put my x plus 2 down here, my x minus 1 down here, my 4 minus x down here. Each of the factors. So I'm going to set it up with my x plus 2. And since you, like, if you're using lined paper, I recommend just putting one on each line and using the blue lines. You don't have to, like, draw a line across. I just don't have lined paper up here. We're going to put our x minus 1 and use a line. And we're going to have our 4 minus x and use a line. And we're going to figure out where pieces are positive and where pieces are negative. And you can do that in columns like we did on the last time. You can take a row across and do it that way. It doesn't matter how we fill in our table. We just need to fill it in. So think about these. Remember, these guys are our zeros, so we're not looking at these numbers directly, but I need something smaller than negative 2. I'll do something between negative 2 and 1. I'll do something between 1 and 4. And I'll do something bigger than 4. So we have a lot of pieces on this one. Excuse me. So if I look over here at my smaller than negative 2, you can pick a number, a specific number. You can just kind of think in general. Something like negative 3 would work. Negative 4 would work. Just thinking through a value. If we think about something like negative 3, if I substitute that in place for x here, is this chunk going to be positive or negative? Negative, because we'd have a negative 3 plus 2, we get a negative 1. What about on this one? If I had negative 3 minus 1? Negative. Whoa, different pen that I meant. No, this one. There we go. What about on this one? 4 minus negative 3? Positive. So then if I have a negative times a positive, this section, is it going to be positive or negative? Negative, positive, negative, negative, positive? Positive. So my whole function down here, and if it helps, you can label this as your function, f of x, because we're taking negative times a positive, and we get a positive. And we get to do that in more places. So then we're going to do the same thing, but thinking about a value between 2 and, between negative 2 and 1. 0. We love 0. 0 is a lovely option. So we think about 0. If I take 0 plus 2, is this going to be positive or negative? Positive. If I have 0 minus 1, is this going to be negative or positive? Negative. If we have 4 minus 0, positive. So then we'd have a positive value times a negative value times a positive value. Negative. So my function will be negative there. It'll be below the x-axis. So then let's think about something between our 1 and 4. 3. Beautiful. Switching that. So if we're just kind of thinking 3, you don't have to use exactly 3. You can use 2. You can use 2.5. You could, get real froggy if you want to. Is this piece going to be positive or negative? Positive. How about for this one? 3 minus 1? Positive. What about 4 minus 3? Positive. And so if I have a positive times a positive times a positive, what do we have for that section? Positive. And one last piece to do. So bigger than 4. I say you can do 5, you can do 10, whatever you want to do. It doesn't really matter what value we're thinking about. We're just thinking about something big over here. Is this going to be positive or negative? Positive. Something minus 1. Positive. So 5 minus 1 would be a positive 4. Totally valid. What about this one? 4 minus something big. Negative. So if we have a positive times a negative, negative. So our function here is starting out positive, then it's going negative, then it's going positive, then it's going negative. So we could, if we really wanted to, and we'll do this eventually, but not right now, do a little sketchy sketch, just so we could see it. It's going to look kind of like this. That was 100% freehand, so the values are not in the right spots. But we want to know when this is less than or equal to 0, so we want to know the pieces where it's negative. So if we look at our intervals down here, where our function is negative, is between our negative 2 and 1, and when it's bigger than 4. So we know we're going to be between our negative 2 and our positive 1. Are those pieces going to get parentheses or are they going to get brackets? Do we get to equal 0 on this one? Yes. So if I can equal 0, I can include these pieces as long as they don't give me a funky denominator. Which they don't, because we don't have a denominator here. So that gives me this little loop-de-loop right here is between our negative 2 and our positive 1. This guy, that's this piece over here, is going to go from our 4 out to infinity. I'm going to write a U in between them. It is technically correct for the way to join them, but not that big a deal. Again, I'm not going to be petty about the U versus not U. Let's do one more of these, and then tomorrow we'll get into some funky ones. Because sometimes we don't actually give you it in factored form. Sometimes we give it to you written as a quadratic. So we've got x squared minus 2x minus 5, and we want to know when that's greater than 3. Uh-oh. So not only do they not give it to you in factored form, it doesn't have a 0 on it. What can I do to make that actually have a 0? Subtract 3, because we have a quadratic that we want to factor, so we need this to be 0. We need a 0 so that we can factor. So we're going to go ahead and start by subtracting 3 from both sides. That's going to give us x squared minus 2x minus 8 greater than 0. We'd really like to have this in factored form so I can figure out where my pieces are that make it hit 0. So does this factor? Yeah. So it would be a pair of numbers that multiplies to make negative 8, adds to make negative 2. What pair of numbers is that? Negative 4 and positive 2. So our factored form here is our x minus 4 and our x plus 2. Be really careful about that. I've had a lot of people play mixed match games on signs, on factoring, on things. So please be really, really careful with your factoring stuff. So what are our zeros on this one? Or our roots? Positive 4 and negative 2. Our roots are where those factors equal 0. X minus 4 equals 0. X plus 2 equals 0. I'm going to make our positivity table. I know we can probably eyeball this one, but it's good practice for us. Our positivity table is going to have our -2 and our +4. I'm going to write each of my factors. I'm going to have my x minus 4 on one line. I'm going to have my x plus 2 on another line. And then we're going to think about our function below as being the product of those two pieces. So this is our whole function. So if we have a number smaller than -2, is this piece going to be positive or negative? Negative. Let's see, I need the color. This piece would be negative. If I have a number smaller than -2, is this piece going to be positive or negative? That one's also going to be negative. So if I have a negative value and a negative value, we actually wind up with a product that is positive. So then if we look in the middle, between -2 and +4, is this piece going to be positive or negative? Negative. So if you want to think of a specific value, that's totally fine. It's also good practice for us to not think of a specific value. How about on this piece? Will this one be positive or negative? Positive. Because it's something between -2 and 4. So something like 0 would be perfect. And so our function here is going to be a negative times a positive, negative. And then we have bigger than 4. This is going to be positive or negative? Positive. And how about on this one? Positive. So a positive times a positive gives us a positive value. And where are we going to find greater than 0? What's our answer going to be? We're looking at greater than 0. Are we looking for the positive sections or the negative sections? Positives. So I want to know where we're positive and when we're positive. So starting here and going this way, starting here and going that way. So our intervals are going to be from -∞ to our -2. We have our greater than, not greater than or equal to, so we know it's going to be in parentheses. And then it's also going to go from 4 to infinity. Again, you can join it with a U, you can join it with an and. I don't particularly care. Technically, a U is the best answer, but again, I'm not going to be petty about the U. Okay? Yes, dear.
I don't understand why we have to like look at the 0. Like, what does the 0 tell us? Is it a positive number? How? Like, I don't understand.
Like these ones in here, or this 0 over here.
That one.
Because we have an x squared, and I need to know where our zeros are, we have to set it equal to 0 because I can't factor this thing. And when I have an x squared, I really don't have any way of knowing where it is above or equal to 3. So we've got to get it set equal to 0 so that we can factor and find our roots. Otherwise, we're going to have to just kind of freehand this quadratic and guess. This kind of is the shortcut for how to figure it out. Otherwise, it's guess and check. And it's gross. Because we would be looking at polynomials of any number of pieces and trying to figure out where it's above and below the x-axis. So as gross as these are, and I understand they take several lines, they're actually the least gross of these. So we're going to work some more with these tomorrow because they will occasionally give us some that are rationals. So we're going to look at what it looks like when we have a rational version of these tomorrow. It's treated the same way. We're going to find our factors. We're going to find all of our zeros. We're going to make a table. And then we're going to multiply stuff. So, homework 2.6, you guys can do everything on. 2.7 is very short because that's the last section. Our test is Friday. If you are missing any quizzes, those need to be made up today or tomorrow because I'm handing all the quizzes back on Thursday. Yes, dear. Okay. Yes, dear.
Did you put in quiz 4?
It should be in. Yes, I put them in, I believe, on Saturday. If they did a funky, that happened.
Because it says I have a 0 in it.
It could just be that I was doing it at home, so things were getting a little grumpy. Okay, keep going. I've been more.
So you use this one to get,
So this is,
but here you
Yep.
use this one.
because this was greater than 0. And so we're looking for greater than 0. We're looking for places where we had positive. Because what we're doing,
So it wasn't these because it wasn't right. They were negative.
because those were negative. So we took our negative terms are positive and we got positive and positive and positive. This is like our total row. Alright. Emily, I got it in my hand right here.
I got it.
I don't know how and this must have like not processed through on my computer.
Okay.
Yep, no, I got it. It's in.
They have a 19.